Okay, gentlemen, let's take a look at our class number 3 of pre-calc, trimester 3. So these notes are in your canvas for you to follow along with as you watch this YouTube video. And then you'll do some classwork at the end, and that'll be class 3's classwork assignment due at 7 p.m. Little review. I'm going to go through this a little quick just because we have some stuff I want to get to. Positive angles go clockwise and negative angles go counterclockwise. We saw that in the Zoom class, and we should be aware of that. Like, that is important to remember. Which way am I rotating? Right? We said we were in standard position if our initial side was on the positive x-axis. The terminal side, where that lands, tells us what quadrant our angle is in. So just like on the classwork assignment, it was, I would give you an angle, tell us what quadrant it falls in. It's based on the terminal side. And then we learned that coterminal angles are ones that have the same initial and terminal side. There can be an infinite amount of coterminal angles because I can rotate around as many times as I want, positive or negative, clockwise or counterclockwise. As long as I'm spinning around, I could always land another angle that started and ended at that exact point. Okay, so let's first talk about this unit circle. We'll go through a couple of notes, and then it'll probably be a little bit hairy as to what this means, and then we'll do an example, and that should help clear it up a little bit. So first, let's graph a circle with radius of 1 and has a center at 0, 0. My equation of a circle is x minus h squared plus y minus k squared is equal to r squared. So that's something we had done in the first trimester, and my center of my circle was 0, 0, and obviously my radius is that r. So we can kind of just plug in what we have and get out our equation of a circle. So x minus 0 squared, very nice, plus y minus 0 squared is 1 squared. This comes out to be a very nice equation of x plus y squared is equal to 1. Right? Very simple. This kind of fell out from our very simple numbers, but this unit circle has an importance in trig, and let's kind of look at a picture on the right. So we wrote our equation. I'm sorry, this is equals 1. Right? Now let's graph it. Okay, so let's look here. Let's do 1, 2, 3, 4. So let's say that point, we'll call that point P. Right? And we'll say that, right, 1 box is a quarter of a unit, right? So every 4 is 1. So 1, 2, 3, this would be 2, right? So this is 1. Now if I do the same thing up above, this is 1. Same thing to the left, 1, 2, 3, 4. This is a negative 1, 1, 2, 3, 4. And this is also negative 1, right? So there's my radius of 1. Here's my center at 0. Perfect circle, first try. Okay, bam, look at that. So there's my unit circle, and it goes around the center, 0, 0, and it has a radius at 1, right? It has the longest points, it's always a distance of 1. Okay, now if we look here, if I took something like this, I'll make this a little bigger so we can see it. If I took something like this, and I put it at 1, exactly right there, nice little magnifying glass, and I spun it around here, right? We would see that right here, for example, my angle that my little blue line creates is like maybe 30 degrees or something like that. I keep going up, following along my circle. Now my angle is at something like maybe 70. Now I'm at 90. Right? We kind of saw that the other day. If I keep going, now I'm at something like 120, 150 or so, 170, and now I'm at 180. And now down here, I'm like negative, but my angle is 210, 250, 260, and now I'm at about 270, even though I'm in like the negative area of my coordinate plane. Now I'm going this way, and I'm like 300, 330, and 360, right? So I can take that blue line and kind of follow this all the way around. And I'm getting a 360 degrees, right? The circle adds up to 360. If I just take a line and I just drag it, I get 360, and that's kind of what it says right down here. Point starts at 1, 0, that's where we started. as it moves counterclockwise, which is positive, direction along the unit circle, the measure of the angle formed by the x-axis and the terminal side, that was a blue line I was dragging around, starts at 0 and increases until it reaches 360. Essentially what you're saying is a full circle adds up is 360 degrees, and you got to pick a spot to start, and you end at that same spot. That's a full 360. Unit circle is just a center at the origin, and the radius is 1. There's my equation of a unit circle. There's my picture of a unit circle. Okay, great. What does this mean? How does this relate to what we're doing? Well, let's look at some graphs. So I kind of graphed them in Desmos already. And you could probably take the time to do that. Whoops. But I took the graph of each one. I'll pull up Desmos. All right, so here's sine of x. It's the red one. If we look at this, right, the highest it goes up to is 1. So it's bounded by 1 above, and it's bounded below by -1. What are all these pi's over 2's? Like pi, 3 pi, 5 pi, 7 pi. What does that mean? Well, we're going to get to that eventually. That's radians. And that's probably next time. If you look at cosine, right, if I tap cosine, it looks almost exactly the same, except here sine starts at 0, and here cosine starts at 1. Here, on blue, cosine is at 0, and sine is at 1. So there's this really weird relation between sine and cosine. And then we see tangent, just what is tangent? We don't know. I look at it, it doesn't really look like it relates to anything. There is a very nice relationship between cosine and sine and tangent, and you can see that they kind of overlap at times, and then there's asymptotes at tangent that have a relation to the other functions. They're really, really nice. But for now, I just took a screenshot of each graph, sine, cosine, and tangent. I just took a screenshot of each one. I had done this before, so I'm just going to grab each one, all photos. Bam, bam, bam. And here's my 3 photos. And I'll just make them a little bit smaller. And there we go. Right, so we have sine, cosine, and tangent. Right, I'm not going to make them super nice now, but that's the 3 of them. Okay, so here's sine, here's cosine, and here's tangent. And there's all 3 of them. Okay, so there's my graphs. So now there's this GIF or GIF I have that kind of helps show the relation between the unit circle and the, let's see if I just had it saved, pastes. Nope, not it. I just had it saved to a math right here. And so, okay, so if we look here, this picture shows the unit circle over here on the left. And then here's my sine curve. Starts at 0, goes up to 1, down to 0, down to -1. If we look here, bam, I'm at right about at 90 right there, and I'm at 1. And I go, and I'm at, bam, bam. I'm at 180, and I'm at 0 on the coordinate plane, which makes sense. I'm kind of flat. And now I'm down at my lowest point, and that's -1. I'm at 270, which is the amount that the circle is colored in. And then I go up till 360. Okay, so there's a relation between them. I hope that helps a little bit. Now let's look at this. So, right, we see that there are some points when the unit circle is positive or negative, meaning it's above or below the x-axis, right? We see as this circle is spinning on the right-hand side over here, I'm positive, and then all of a sudden when I get below, I'm negative over here. So there's times when sine is positive and times when it's negative. And there's a little acronym to help us remember that. And that acronym is all students take calculus. All students take calculus. And that's related to the quadrants. All right, quadrant 1, 2, 3, 4. Right, and there could be anything. You could say anything you wanted to remember. ASTC, it could be anything you want. If you were in Dr. Summers' class, you can say, and Summers teaches calc. Whatever you want to say. Something to help you remember it. But this is what we want to know, is that in quadrant 1, in quadrant 1, every trig function is positive. And why is that? Well, positive, positive. I'm going positive x, positive y. In quadrant 2, only the sign and its reciprocal are positive. And why is that? Well, because if I look here, right, I'll just do this kind of for the first one. There's my theta, opposite, positive, and hypotenuse, that's always going to be positive because it's a squared plus b squared is c squared, so it's always going to be a positive number. So positive and positive is going to be positive, obviously. But if I look at adjacent, that's negative over positive is going to be negative. If I look at tangent, opposite over adjacent, that's negative. So the only one that's positive is sine. Same exact idea down here, where I have theta, opposite, hypotenuse. Now that's negative, because this is always positive. Adjacent and hypotenuse, still negative, but tangent is positive because it's opposite and adjacent, and that's going to be negative over negative, so that's going to be positive. So quadrant 3, the only thing that's positive is tangent and its reciprocal, cotangent. And then the same thing occurs here, theta, opposite, that's negative, and then your opposite over adjacent is negative, but your adjacent and hypotenuse, that would be positive, right? So your hypotenuse is always positive. And then everything else is kind of based on where it falls in the coordinate plane. Okay, so all students take calculus. All things are positive in quadrant 1. Only sine is positive in quadrant 2. Only tangent is positive in quadrant 3. And only cosine is positive in quadrant 4, including their reciprocals. Okay, so let's do an example. Kind of makes sense better if we do an example. All right, so let theta be an acute angle in standard position. So here's my coordinate plane. Okay, so I got theta. It is in standard position. So that means I'm starting right here. Okay, here's my standard position. Terminal side, okay, contains the point 5, 3. All right, so 5, 3 is about 5 over and 3 up. So let's say it's right here. 5, 3. That's the terminal side. So that means here's my terminal side. It contains the point 5, 3. Here's my theta. Initial side, terminal side, with the point 5, 3. And I want to find all 6 trig functions of theta. So the first thing I do here is I can't do sine, cosine, tangent, SOHCAHTOA without having this little bow tie thing in the middle. So I can't do anything, but if I drop this perpendicular line, now I can. Now I've created a right triangle for me to be able to find all my trig functions. So there's my little right angle. Okay, once I've dropped my perpendicular, it can help me figure out, well, what do I know here? Well, this length is told to me right here, 5 over, and how much up? 3. All right. Standard position, acute angle. Terminal side with the point 5, 3. Meaning 5 over, 3 up. Dropped a perpendicular, so I got my little right triangle. This is my hypotenuse. That's my hypotenuse. Except, what is that? How much is that? Well, very easy to find. What's my hypotenuse going to be? A squared plus b squared equals c squared. 5 squared plus 3 squared is equal to c squared. 25 plus 9, 34, radical 34. That's my hypotenuse. Radical 34. Oh, Francis, that's a terrible number. Nah, it's okay. Radical 34, we can deal with that. No need to rationalize our equations here. We're just going to write all of them out. All right, so let's start to write them out. So all 6. Sine of theta, cosine of theta, tangent of theta. What goes with cosine? Cosecant. I'm sorry, what goes with sine? Cosecant. What goes with cosine? Secant. What goes with tangent? Cotangent. Okay, so now I wrote all my 6 trig functions out. The ones we know, they're reciprocals. Okay, I have my opposite, my adjacent, my hypotenuse. It's in standard position. From my acronym, all students take calculus. A, all. Everything is positive. Everything is going to be positive. I'm in quadrant 1, nice and simple. What do I do here? Brings us back to geometry and what we did in class 1. All we have to do is just name my ratios. So sine, opposite over hypotenuse, 3 over radical 34. Done. That's it. You found it. You can write the decimal approximation, but I like the fractions better. Cosine, adjacent over hypotenuse, 5 over radical 34. Done. You found cosine of an angle such that you go through that point. There it is. Tangent is opposite over adjacent, 3 over 5. Okay, everything's positive. Nothing was negative. Now, very simple, our reciprocals are always the reciprocal. So I can just flip my answers here. Radical 34 over 3, radical 34 over 5. See, I just flip those. I flip those, and then I flip these. Nice and simple. Right? You could find them on your picture, right? As a bit of opposite over hypotenuse, it's hypotenuse over opposite, but I think it's easy just to kind of know the pairs and flip them. And there's our work for the first one. So we have a unit circle that's kind of being formed here, right? We're pulling this point, and we're starting to drag it around the unit circle, and we're finding the ratio as if I were to stop it and say, what's the ratio? What's the angle? Okay? So good on that one. Let's do another one, and then I'll give you guys some classwork. Okay, so let theta be an acute angle in standard position. Here's my coordinate plane, standard position, whose terminal side contains point -2, 4. So here's my standard position line. Okay, initial side contains a point -2, 4. So I'm kind of up here. -2, 4. So now I'm in quadrant 2. Bam. There's my -2, 4. So bring this right. Oops. I'll bring this over here. Okay. Here's theta. Nice big angle. In quadrant 2, looks like I'm something like 120 or maybe 110 degrees, something like that. Okay. So now if I look here, if I drop this perpendicular, just as we had before, okay, drop my perpendicular. The only problem is my theta is way over here. My theta is way over there. So how is this going to help me? Okay, so we look here. Actually, it's not acute. That's a typo there. I shouldn't say acute. Here's my right angle. Right? But what's my theta? This is my theta. I got to get back to 180. Why did I write a little r there? We call that the reference angle because I'm getting towards the positive x-axis, but it's not my actual theta, right? It's like 180 minus my actual theta, so it's supplementary. Okay? All right, so what do we know? So this is still -2. That we know is -2, and this is +4. We still got to find our hypotenuse. Still got to find it. We're going to do it the exact same way. A squared plus b squared equals c squared. 4 plus 16 is equal to c squared. 20 is equal to c squared. Radical 20 is equal to c, or you can call it 2 radical 5. And that's my hypotenuse, 2 radical 5. Right, and as you can see, this is why my hypotenuse is always positive, because you're squaring things, so of course it's always positive. Okay? All right, so now let's find our 6 major trig functions: sine, cosine, tangent, and my reciprocals: cosecant, secant, cotan. Okay, I'm in quadrant 2. All students take calculus. The ones that are going to be positive are sine and cosecant. The other ones should be negative. Okay, well, let's see. So my sine of theta is going to be from my little reference angle, it's going to be opposite over hypotenuse. So I got 4 positive over 2 radical 5. Okay, I'm using my reference angle there. Cosine is going to be adjacent over hypotenuse. And if you look, there's my negative, negative 2 over 2 radical 5. It is negative, and I expected it to be. Tangent is opposite over adjacent. So negative 2. Nice and easy number, negative 2. See how you can see how tangent is kind of so weird, but it's a negative number. My reciprocals, 2 radical 5 over 4, 2 radical 5 over negative 2, so I just put the negative out in front. Go like this. I usually just write the negative out in front. And then 4 over 2, or negative 2, I can just write it as negative, or I'll do it like this, 2 over 4 over negative 2 over 4, so negative 1/2, right? And we can see that those are my answers right here, 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 and here, and these are my positive answers. But those are all my trig functions from a standard position when I know the terminal side goes through a certain point. Right, so here's my answer. Right, and this one's, sorry for the typo there, this should say not acute, but give me an angle in standard position. Right, and we had to use what's called our reference angle, and I'll do a small example of that below here. Right, but for the second example, we see that theta is any angle that contains, again, this, sorry, typo here, negative 2, 4. There are infinitely many coterminal angles that could play the role of theta. Some could be positive, some may be negative, right? So if you keep flipping around the circle, you can get more than one answer. The values of the 6 trig functions could be the same for all of them. Right, and we see here's our little picture. You have sine of theta, cosine, tangent, and then my reciprocals, cosecant, secant, and cotangent. Okay, I'll just draw the picture for this, but it just is talking about your reference angle, and it's kind of what we were talking about up above there. But if I say my trig function's 210 from standard position, at 210, 210, okay, so 210, I'm going around the circle, and I'm somewhere over here in quadrant 2, just like the one we saw above. Here's my theta, here's 210. Right? Draw the reference triangle. So we just kind of saw up above my reference triangle. Down here, here's my perpendicular. And what's my reference angle? Well, I got to get up to, 210. 210 is going to be way down here. 210 is going to be way down here. Right? And here is 210. Okay, draw my reference angle. I want to get back to my flat x-axis. So here's my perpendicular line. What is this angle going to be? Well, this is 180. That's 210. So I'm exceeding by 30 degrees. 210 goes all the way up to here. 180 is only up to here. So how much more from 180 am I going? 30 degrees. So now I've created a 30, 60, 90 triangle. And that, we know those relations on those sides. It's kind of the same idea. I could do something like 315 and be somewhere over here, and then my reference angle would be 45 degrees, right? So we use the reference angle because we want to drop a perpendicular so that we create something like this bow tie, right? So we're creating something like that bow tie. I know it's a little confusing. I'll zoom in just so we can see these two screens. Very important to understand the idea of finding your reference angle, and once we're able to draw the picture, really finding these is the easy part. It's really understanding the pictures that's the hard part. Right? And we're using our reference angles here. Okay? For your classwork, here are 3 problems, right? Quadrant 1, this is in quadrant 3, and this is in quadrant 4, right? So you gotta, first one's a little straightforward. 3 and 4, number 2 and 3 may be a little difficult, but do your best on that, and then we'll go over it.